going if
There we go.
We can send this, you guys, if you do want a copy of this after, let us know because we can send you an email with a copy. Okay, let's go ahead and get started.
All right, so this is a portion of weather. As we know, it's a huge topic. Let's see. There we go. So if you are not familiar with the ACS is a testing document. Examiners use it for the practical exam, and us instructors use it to get you ready for the practical exam. So as you can see here in the pre-flight preparation under weather information, today we are going to talk about weather system formation, including air masses and fronts, okay? This is something called a surface analysis chart, and for this one, it is called a prog chart. This can be found if you're familiar with the ForeFlight on the iPad. This can be pulled up on ForeFlight as well as aviationweather.gov. This is something I use before planning across country or even my lessons before the day. Like yesterday, those of us in California, I could have easily predicted the weather just by this prog chart and what was happening. I test myself. Some days when I'm not flying, I'll go ahead and look at the prog chart and I will look outside and say, hey, I predicted the right thing. That's how I test myself with some of this stuff. And you will get really good at it by doing that. So some of the things it depicts, well, actually not on here. First thing we talk about is air masses. So there are multiple different air masses, and an air mass is a body of air with uniform temperature and humidity. Now, air masses can form over different parts of the world. We have polar air masses. Those can generally form over places like Alaska or even Canada, both over land and sea. Then we have Arctic air masses that are drier, and those form over the Arctic latitudes. We also have tropical, and those form over tropical places like Hawaii or the Gulf of Mexico. And those have a little bit more warm temperatures and a lot of humidity. Now, these all play a part in our weather as they flow from East Coast to West Coast. So this now comes into play because we have fronts. I will move on. So we will revisit this as I keep talking. The first front we have to talk about is a cold front. Now this, I'll go back. This is here, this blue spiky area on the chart. This is what it looks like, not on the chart, but a visual representation of a cold front. A cold front here, if you can see where my mouse is at, this is like an atmospheric cloud. This is cold, dense air. This cold front, so this air mass here, moves about 20 to 25 miles per hour, usually faster in the wintertime and slower in the summer months. But this acts as an atmospheric cloud. See this coming in? This pushes warm air up. So this warm air here. And because it does it so rapidly, we can expect things like cumulonimbus clouds or cumulus clouds. And if anyone knows anything about cumulus clouds, you can expect turbulence, okay? So not only turbulence, but they also are associated with things like squall lines, which are embedded thunderstorms, which we would not want to fly through, thunderstorms in general, and frontal turbulence. So I just, that air rapidly moving up, you're going to expect some turbulence. Let's see. Can anyone add, Jamie or Janelle, anything about a cold front? You're going to get showery precipitation like it says on the slide. You're going to get hazy visibility, but as it clears out, you're going to get good visibility. So visibility is really important, especially if you are just a VFR private pilot, right? But showery precipitation. So you're going to get those cumulus clouds here. This is what I'm talking about. So we're going to have spotty showers. It's not going to be consistent, right? Whereas if anyone who lives in California yesterday, we actually had some high or some stratus clouds here, and in the beginning of the day, it was pretty solid rain, and then it broke out into, you know, spotty, showery precipitation.
And that's why it's good, like you said, to always look at the prognosis charts. And when you're kind of learning the weather, you look outside and you don't really kind of know what's going on. And then you back it up with looking at those charts. And then then you kind of get an idea of what it means. Because seeing it on paper like this is great, but actually seeing it outside and seeing it on paper. So that would be like my definite suggestion is for you guys to start paying attention to what's outside and what fronts are going on, and seeing it in and outside. And then when you see it on paper, you know exactly what's going on outside.
Exactly. So, and I will go back to this chart. That again is this blue area, or this blue line. So essentially there's a cold air mass pushing a warmer air mass up. And that's what this line depicts. So the next one we have is a warm front. A warm front, I'll go back to the prog chart. We have a warm front here, this red with the half circle. Don't pay attention to this here, but this is what a warm front would look like, and it would stretch all the way across. This one is just smaller. So here, instead of an atmospheric plow, we have more of a nice slow ramp. This one is a warm air mass overtaking a colder air mass. Now, warm air masses, they move slower, about 10 to 15 miles per hour, and sometimes even slower. So this one, the warm air is being pushed up and over the colder air mass. And this is more gradual. So you're not going to have severe turbulence like you might with a passing cold front. You're going to have higher stratus clouds as depicted in the picture. You're going to have poor visibility. You can expect overcast skies. And then also precipitation. This is going to be a more steady precipitation rather than hit or miss showery precipitation. Just like in the side, think of a blanket over the sky. Let's see. So here, if it's raining above and it's warm, and it is now, so say here, it's raining, falls into the colder air mass. This is where widespread fog can happen due to the warm air now cooling and entering its dew point. Does anyone have any questions on that? No? Sound good? All right. So the things here in the slide is something that a DP is looking for, or what you would want to know when looking at a prog chart. What type of clouds am I going to have? Am I going to have good visibility or poor visibility? And what type of precipitation am I going to have? Next one. So here I just made a slide of the difference between a cold front versus a warm front. Here it looks like an atmospheric plow. You're going to get those cumulus rising clouds. Whereas here, the warm front, you're going to have more stratus clouds, not too much rising air. So this one, we're probably going to have more turbulence here than the warm front. Does that make sense? Okay, next one is a stationary front. I will revisit the prog chart. The stationary front looks like this. It's both red and blue. So this stationary front goes from Canada all the way down to Texas. Now with the stationary front, it's going to be a battle between a cold and warm air mass. Not one is stronger than the other. They're kind of battling it out until one overtakes another. So for this one, weather is going to be different depending on which side of the air mass you're on. But if you're here in the middle to where they're kind of battling it out, you are going to find calm surface winds, low-level stratus clouds, and let's see, steady precipitation and possible instrument conditions. So if you're a VFR pilot, You would not want to find yourself in instrument conditions if you are not rated for instrument. Let's see. So here, I mean, when I say it is different on each side, we could have, if you're from California, we could be over here in the, let's just say the Eastern Sierras versus here, the, you know, the coast, as in like Monterey or something, and they could just be battling out along here and it could sit there for a few days. An occluded front, now these ones, I personally stay away from. This is what happens when well, actually, let me revisit the prog chart. They're kind of hard to spot. They are these purple ones here, and they're usually attached with a cold and warm. They kind of hang out together. There's also one up here. And I know there was one forming today on the West Coast, or yesterday on the West Coast. So here it's that purple depiction on the surface analysis chart. And this is what happens when a cold air mass overtakes a warm air mass and then meets up with another cold air mass. So as you can see here depicted, this is over a large span area, and weather is going to be different in each one of these cities. But this type of front is very unstable, and this is why I choose to stay away from them if I can. You often see cumulonimbus clouds, the big thundering, you know, thunderstorm clouds. You're going to see possible thunderstorm, if not a thunderstorm, and gusty winds. The difference here is weather aloft, meaning up here, is going to be different at the surface. Big thing here is if it's raining aloft, and that, like I said, in the warm front, if it's raining aloft and hits a colder temperature, say it's freezing temperatures down here, you could get freezing rain, which is dangerous. You can also get freezing rain and sleet. Let's see. So as you can see, over a wide span area, St. Louis, we can go ahead and read the METAR. And for those of you who are newer, we will get, you know, used to reading these, but I will go ahead and help you out. So here in St. Louis, in this first cold air mass, we are getting winds at 310-23 gust 40 knots, okay, with 8 statute miles visibility. So that would be a no-go in Little Bluebell or my 150 or Light Sport, right? As we continue on to Indianapolis, where the front is meeting the other cold air mass, winds are picking up even more. So these are 290-28 gust 45 knots. Visibility has increasingly decreased. Sorry, that was wrong verbiage, but it's now half statute mile visibility. As a VFR pilot, I would not want to find myself in that situation. Moving on through to the next cold air mass here in Columbus, you're seeing winds 160 at 17 knots. So they are decreasing, but visibility is still 2 statute miles. And we got some baby rain. Moving on to Pittsburgh as we continue on with the mass, weather's getting better. It's 130 at 12 knots with, what does that say? That actually says what, 75 statute miles? But so it's getting better. So this is why it's really important if you are planning a cross country to not only check the city or check the prog chart, and then check multiple cities around it. If you have to divert, you want to make sure that, you know, the weather is still going to be good on either side as you move through the front, if you wanted to move through the front. Here's a good depiction of the clouds here where the air masses meet. So here you're going to get more cumulonimbus, those thunderstorm clouds. And then as you move on, they're going to get higher and higher. Visibility is going to get better. And as we saw, it did increase to a large visibility. Let's see. So here I created just a little test. I don't know if this is kind of hard to read, but just to kind of recap on some of the air fronts that we learned. And I don't know if I said before, but a front is a boundary of the air mass. So that means where two air masses are meeting. So let's, if I would love for you guys to chime in on this. I'm going to read it and let's see which one we can match it up with. Okay. So the first one we hear, it says under Bravo, cold, dense air forces warm air, which is less dense up. Intense precipitation, heavy rain, snow, and sometimes thunderstorms. Just from looking at the pictures that we have, which one do you think is going to produce thunderstorms? This is cold, dense air, pushing it like an atmospheric plow up. Is it a warm front, occluded front, stationary front, or cold front? Anyone take a guess? You could put it in the chat if you don't want to talk.
It's a cold front.
Yes, it's a cold front. Nice job. So we got cold front out of the way. That is here. Good job. The next one is when two air masses meet up, but neither advances. The boundary between them stalls. There can be light winds and precipitation. The wet weather can last for several days. So which one of these is battling it out? Is it a warm front, occluded front, or stationary front?
Stationary?
Stationary. Nice job. All right, the next one is sometimes a cold air mass moves so rapidly that it overtakes a warm front and forces the warm air upward. As the warm air is lifted, the advancing cold air mass collides with a cold air mass in front of the warm air front. Strong winds and a lot of precipitation are common. So we have occluded front or warm front. (50-50).
Occluded.
Occluded. Nice job. Nice job. All right. So the last one, warm air displaces cold air and can cause light precipitation and drizzly rain. Anyone want to take a guess?
How about a warm front?
A warm front. Thank you. All right. And we can match the symbol with the terminology. So let's see. Does anyone remember what this one is?
Cold front.
Cold front. Nice job. And this purple one?
The occluded.
Occluded. Good. And then the red and blue?
Stationary.
Stationary. And last one, the red.
Cold. Or warm, yeah.
Warm. There you go. All right. And this last one, this type of front brings drizzly rain and followed by clear and warm weather. Well, technically we did these with this. So we can skip over these. It's pretty much the same thing. All right, let's go ahead and continue on with the prog chart before we move on to pressure systems. So there are more symbols on here than what we talked about. We talked about fronts here. And if you look here, this front, the spikes are kind of close together. This is actually called a forming cold front. Where this one has spaces in between it, this is a dissipating cold front. So it's weakening. Here we have these lines. These are called isobars. They're lines of equal pressure. Now, you see this number 1016. If anyone has done some ground school, when we move our altimeter setting, we use inches of mercury. So that 29902 is standard pressure. On the prog chart, we use millibars. Now, standard millibar is 1013. So here's an equal line of pressure of 1016 millibars or 1016 millibars. The closer these lines are together, the windier you can expect the area to be. The further they are apart, the less wind you can expect, more like winds calm possibly. This number 1016 right here is associated with the isobar, whereas we have some underlined ones. These underlined millibars are attached to these, I just lost my words. They are associated with the pressure system, so high or low pressure. So the ones that are underlined are associated with pressure. The non-underlined ones are associated with the isobar, okay? So here we can expect winds to probably pick up, and it's also following a cold front, so it's probably super windy over here. Where here, if you're in California, winds are pretty light and variable today. So that's what this prog chart is telling me, just from the isobar itself. What else? So we covered the fronts. We'll talk about the pressure systems. We got isobars. This yellow line here that's attached to this L, this red L, that is an extended line of low pressure. That is called a trough. Can everyone see that? Right here?
Yep.
Perfect. All right, so now let's go ahead and talk about low pressure and high pressure. So when I found this picture, I loved it because I can't tell you how many times myself I've gone over low and high pressure, and sometimes it just does not click. So I hope today this helps for everyone here. So this low pressure here, well, first of all, for pressure systems, you have to think vertically, okay? Just how this picture depicts. As air rises, we can expect it to cool. So as the atmosphere, as we get higher up in the atmosphere, we should expect it to cool unless there's a temperature inversion, but that, you know. So as air rises, it cools and we can expect water vapor. Sorry, hold on. As air rises, it cools, which can cause water vapor in the air to condense into liquid water droplets, sometimes forming clouds and precipitation. On the other hand, sinking air is going to warm up as it falls into the atmosphere. So as we think rising air, we can think as it condenses, causes clouds and moisture. Versus sinking air, it's going to warm up a little bit as it gets closer to the surface. So let's think of a low pressure system. As you can see, air is coming in and condensing. And because it's condensing, it has nowhere to go but up. It can't go down because the Earth's surface is there. So as air condenses, we are now forming, as air condenses, we're now getting moisture depending on where this low pressure system is coming from or how much moisture is actually in the air will depend on the cloud cover you're going to get. So let's see, think of a balloon. If you have a balloon and you squeeze it, what does that air want to do? It wants to go up, right? It wants to pop as you squeeze a balloon. Same thing with a low pressure system. Okay, so then we're going to have cloud cover in a low pressure system. Well, as that cloud cover comes up, it now wants to, it'll either rain or the clouds will move. And then if we have a high pressure system coming in, possibly behind it, that air is going to want to replace what that low pressure pushed up. So now we have descending air, okay? Here with the low pressure system, you can expect turbulence because what? We have rising air. Whereas a high pressure system comes in and replaces that rising air, and we can expect some nice, smooth, calm air. Visibility wise, a low pressure system is going to be better because it's pushing everything up and away. Whereas a high pressure system, we won't have clouds, but if you notice here in California, we get a haze. It's visibility is still good, but we get a little bit of a haze layer. That's because the air is stable. It's not being pushed up and out of the way. Ooh. Another thing to note, in a low pressure system, low pressure wants to rotate in a counterclockwise. And this is associated sometimes with cyclones and or hurricanes. Right, Jamie? Yes, okay. Whereas a high pressure, the winds flow clockwise. Now, this can also help with cross-country flight planning if you want a headwind or a tailwind. Most of us want tailwinds. Speed us up a little bit, right? Let's see. So with the high pressure system, the air is going to be a little bit more stable. Visibility will be somewhat, I don't want to say poor, but you're going to get some of a haze layer. And winds are going to be calm. Whereas a low pressure, you can expect turbulence, unstable atmosphere, clouds, right? And possible precipitation. If anyone knows anything about compressors, after running a compressor for so long, you have to drain water out. Same thing with a low pressure system. That air is condensing moisture into clouds, okay? I know that's a lot.
It's good.
Does anyone have any questions about low and high pressure before I go on to the rest of the chart symbology? Or any questions at all? Do we have anything in the chat?
Nothing in the chat. I'm looking.
Okay.
Come on, guys. Anything? I love the little questions, the little test you gave us, Alicia. That's good.
They did really good on it.
That was good. Yeah, I know. I was impressed. All right, no questions, I guess.
All right.
Wait, I have one.
Okay.
So then if the high pressure area is considered a haze, what would fog be considered? Would that also be considered a high pressure system?
So fog is completely different. Fog is going to be, yeah, don't think of fog in this. Unless,
Haze you can see through, fog you cannot. Just think of
Right.
it that way.
yeah,
Right.
fog forms differently, and I can do a
Okay.
whole nother lesson on that.
Oh, okay. You're good.
There's 4 different types of fog, and they all form differently.
Right.
Okay. Good question, though.
We'll do
Anyone
a
else?
we'll do a lesson on that.
But when she's saying that, like, associate the haze with that high pressure bringing everything down, when we have that lifting action, it's clearing everything out. So it would like lift up all the particulates and have a clear, nice day. When we have the high pressure bringing everything down, that's when we trap those contaminants and you can have haze and poor visibility. So that's what she's wanting you to correlate there. Does that make sense versus fog?
Yeah, that makes a lot more sense. Yes.
Okay.
Thank you, Janelle.
It's like
Okay.
stagnant air.
Yeah, exactly. It's not moving.
Perfect.
All right, so this is a lot of the symbology you will see on that prog chart. So we did go over a cold front, warm front, stationary, occluded. I have very rarely seen a change in front type with the little bars, but could be on there. This is a forming cold front and warm, cold and warm. It's that frontogenesis. Nice big word. Here we have a trough. So let's see. I showed you guys the trough,
Mhm.
the extended line of low and pressure. Good. That's something we didn't talk about is a dry line. So I will go back to the prog chart. And there's not one depicted on here, but generally you will see a dry line in the middle of Texas. And what a dry line is dry air coming from the ground or the air here. So it's going to be drier, meeting up with moist, warm air coming from the Gulf of Mexico. And what happens is they meet in Texas or Oklahoma, and you will see severe thunderstorms, possible tornadoes, that squall line. It's just polar opposites. You're getting dry air mixed with severely humid air coming together. Okay. So you will see that line generally right here. And I preferably like to stay away from those as well. So we have the dry line. Ridge, I've never seen a ridge depicted. A ridge is a extended line of high pressure. Anyone chime in if they've ever seen one? Yeah, I've never seen one. A squall line. So that is something that can be associated with a cold front, and you will see this depicted on here, definitely. And that's embedded line of thunderstorms. So that's a no-no. All of these right here are the same, fronts. The only difference is they're dissipating. So they're getting, they're not as strong as a forming cold front. High pressure, low pressure, tropical wave. I have not seen, anyone chime in if you've seen a tropical wave depicted. And then a tropical depression, tropical storm, and hurricane. You will see these during hurricane season. Does anyone have any questions? Nada, you guys are so quiet. So moving forward, where did I get this information? Pilot's Handbook of Aeronautical Knowledge is huge. Chapter 12, weather theory. Weather theory is a lot, but it's so important. There's an AC 0045 hotel, and that's something that the FAA came up with. And that talks about the symbology. It talks about, it talks about everything. Janelle, can you chime in on some of the things that it says on there? Do you remember which one it is?
For the AC?
Yes, the AC.
Yes, and then we have 6 Bravo 2. So it's just more in depth on understanding thunderstorms, turbulence, icing conditions, like very comprehensive. If you upload it to ForeFlight, you're able to search through it and find resources quickly. It has written information as well as visual information. So wonderful aids as far as understanding in depth what we're talking about, like what Richard said about haze. The only reason I know what that is because of this AC, and it gave me a real definition of it. So
yeah. So if you have
very
any
great
questions,
resource.
if you have any questions about aviation weather, the Pilot's Handbook of Aeronautical Knowledge, I feel like gives you a base. If you want to go deeper, dig into this AC. And then I'm a visual person. Embry Riddle on YouTube has great weather videos. YouTube is a great resource. I just know that Embry Riddle, their videos are wonderful. If anyone wants to share any videos that they possibly have for weather, feel free to put that in the chat. Or any other resources that you guys use for weather to share with everyone else on here. That would be great.
I am looking one up right now.
Okay. Oh, thank you, Heather, for putting that AC in there. I appreciate that. All right, well, that's what I have for pressure and fronts and a prog chart for today. So that is going back to the ACS. That is just one point of aviation weather. We could hit all these rest of the topics one day, but that was just one.
There's so
So
much.
lots of noting. What was
There's
that?
there's so much to learn,
There is.
and not to mention continuing to learn, right? Because it's easy to learn it, and then you've got it for your check ride, and then next thing you know, 6 months go by and you don't use it, and then to go back in and redo it. And that's why we do things like this, not just for your privates, for everybody. To even Richard's learning over here.
So I know I'm going to share, I keep it real. Before each one of my check rides, I probably studied weather like 3 times. Once I thought I knew it, I went over it again, and each time I felt like I learned something more. So don't ever feel like, oh, one study, I got it done, because trust me, there's always more. Janelle probably knows the same thing.
Yeah, you never stop learning. Jamie said that the other day.
And one thing I want you guys to remember, they have people that do this for a living and they still don't know half the stuff they should know because weather is so complicated.
Yes.
If you can get the basics, like we just talking about, the fronts, the visibility, the high and the low, just the basic and understanding that will take you very far. Don't try to memorize the whole book. just get the basics of what, each front gives you. And that in itself is just as good, is pretty good. Okay. Don't try to be a weather person because that takes years of training and you still don't know it. And especially me, that's my worst subject. So you take it with me, you get a lot less questions on that stuff because it's very, very complicated.
It is. You think, yeah, it's a lot.
A lot.
All right, I'm gonna stop sharing my screen so I can see everyone's beautiful faces. So that's all I have for you guys. Any questions?
No, that was really good.
Yeah, it was very good. Thank you for doing it.
You've got a few minutes. Do you have a wins and losses chart by chance? You can maybe just pop into that for a couple of seconds.
Let me see. I would have to Google search one.
And like Valerie said, she just put in the chat here that airlines, it's gone. Airlines employ meteorologists because pilots and dispatchers can't possibly know everything about weather.
So true. So true.
Weather is crazy. I feel like I learn something about it every time I fly, even, knowing what you know on the ground and then being in the air. It's like, wait, what kind of cloud is that? What is it
Yep.
gonna be? What's in that cloud? Lightning. We had lightning today. We flew to Phoenix and they said lightning in the vicinity. I'm going through the darkest cloud in the area and I'm going, well, is it coming our way? Where is the lightning? When is it gonna strike? I want to be a Miley Cyrus. Her plane, I don't know if you guys saw her plane got hit by lightning and they had to do an emergency landing.
Oh, I did not see that.
Yeah, this happened the other day. Mhm.
See.
Any luck?
Give me just a second.
Okay.
And for those of you who are new, just this is a lot. Just take baby steps. There was a lot of good resources that Alicia put up there. Read those books and watch those videos and it'll start to make sense.
Are you talking about this one?
That's the one I'm looking for. Yep.
Perfect.
We'll let you explain it.
No, I'm gonna let her do it.
Oh, you're gonna let me explain it?
it.
Yeah, I mean, so this is another great resource for winds aloft. This is on aviationweather.gov. It shows surface up to, flight level 480. Right here, it says wind speed. And essentially these bars show the wind direction. So if we wanted to pick, let's see, I can't zoom in, but okay, so let's come out the coast of California here. Looks like winds are coming from the north, correct? It comes, typically there's a ball here. So winds are coming from the north and each one of these bars means something. So if you look at this one, I know it's small, there is about a half bar. That means you have 5 mile-an-hour winds. Whereas these long ones are 10 knots. So 5, 10 for a total of 15. So winds are coming from the north at 15 knots. Whereas we come over here, they kind of lose their bars. So winds are probably calm and they shifted, now coming from the west. As we move along, let's see. I don't see, oh, over here on the East Coast, let's see, this one has 3 bars, meaning it's 30 knots. If they had a triangle at the end, that means it would be 50 knots, correct?
Correct. See if you can get one at a high altitude that we.
Okay, yeah.
It will usually come up one. Yeah.
There we go,
Exactly.
down here. So those larger bars, those are each 50. So over here on the East Coast, we're getting 110 knots up at flight level 300, meaning 30,000 feet.
And you can see by looking at it, if you follow the lines, it shows you how the wind pattern is. Starting from like, if you go from the west, it just goes towards the south. It comes back up again. It's like a wave, as you can, just like a mouse is showing. You can. That's how a lot of pilots, depending on where they're flying, that's how they shoot. Sometimes they'll take a longer route, but because the longer route gives them more of a tailwind, they actually get there faster. So,
Yeah, first, if going up north, you get a headwind
exactly.
coming in
You go-
here. Yep.
Exactly. You go south and then you get a tailwind and you get there, you get to your destiny a lot faster.
Yep. Does anyone have any questions about this? Let's see if they. So it looks like I want to take the southern route
Exactly.
if I'm going west to east.
Exactly. Once you see if you can get to 3,000, something at 3,000, where Bluebell would fly. Then
Where
you-
Bluebell would fall. Yeah. So looks like winds are calm here.
Exactly.
Same with all down here, but here we're getting about 30
Yeah.
and 20 out here. So coming from the north, and here winds are going the opposite direction. All right, that's all I have for that chart.
Yeah,
Do you have
this-
anything to add?
anything
No,
to add?
nothing for me.
For everybody,
Okay.
this website is a good website to go on. You can learn so much stuff and just play around with it.
Yep, so you can go to forecast, turbulence, icing, prog charts.
And a lot of it won't make sense at first, but then it will start to
Yes.
come together.
Yep, this is a dry line right here. That's that dry air mass meeting with a humid, warm air mass meeting together here in Texas.
Okay, I have one thing to add on the winds we were just looking at.
Okay.
Maybe it's too much, but if anybody correlates what Alicia was talking about later with earlier, sorry, with the high and low pressure systems on how the wind moves around them.
Yes, actually,
We
that's a
have
good
that
one.
wind change.
Let's go up a little bit higher.
Mm.
Or did you want the surface?
Any of them.
Okay,
Well,
Yeah.
maybe, yeah, there we go. This one's good. But how the winds change around the,
the pressure system. Yeah,
like you'll
Let's
never,
see.
again, never stop learning. I'm like, I don't know if it's too much, but there's a lot.
it is. And just like Jamie said, they take baby steps. I
Mhm.
had to digest this 3, 4, 5 times. I spent
Same.
probably a week on weather at one point. Because the second you think you get it, you don't.
Yeah, and we'll come back to different sections of weather for our ground schools. And if you guys have a certain subject that's just like something you want to know more about that you already know, or even if you have the information on it that you want to share with us, and share with everybody, let us know. Shoot me an email or message or get a hold of one of us, and we will put it on our agenda for one of our ground schools. That way we can better educate everybody and have fun and share experiences. Maybe you've got a weather story. Maybe you read the weather wrong and thought it was a tailwind, it was a headwind, and it cost you a lot more fuel. Whatever it is, let us know and we can go back into more stuff. There's so much more in weather and icing and all kinds of fun
Yes.
stuff.
Definitely. But that's all I have for today.
Okay.
So-
Anybody else? Any questions, comments? Anybody want to add anything?
For the next meeting, anybody has any suggestions on what topics they would like to hear? Send an email, a text. Planning on trying to do some aerodynamics, some basics aerodynamics for the next meeting. And if you have any specific questions, let me know. Okay, and we'll go from there.
That's a good one. Aerodynamics is a fun one.
I'm just going to do the basics next in 2 weeks. That way I can hit the easy stuff, and then maybe at the second at another time we can go dive into it a little more complex.
Sounds good.
Yeah,
But
sounds
it's
great.
but it's easier than you think. If you apply common sense, you'll see how easy it comes to you. Not like weather. Weather is hard for me, I can tell you right now.
Weather's
Aerodynamics, very easy.
All right, I'll let you teach that one.
We.
All right. Well, thank you guys for being a member of Girls Love to Fly, and thanks for being a friend. And we're here, like I told them earlier before you got here, because he was late. He was doing a check ride, but I said you're here for all of their check ride questions.
Exactly. Any questions on check ride,
And,
let me know.
You know, all that good stuff. So
That's
All
great.
Appreciate
Thanks
all
so
the
much,
great
Alicia. That was
resources.
great.
thank
Yeah.
you, Alicia.
Thank you. Good job.
You're welcome.
Thanks, everyone.
All right.
Bye-bye,
Bye,
guys.
everybody.
All right, bye.
Next time.
Bye.
Bye.
Damn it.